Hi everyone, and welcome to today's session with me, Melissa, the in-house math teacher at ICS Learn. The details, as always, are there on the screen. And today's session, I'm going to introduce you to probability. So just the very basics of probability and how we work it out. The session will last about 1 hour, might be a bit under. See how we get on. I'll give you some extra practice questions if we've got time. And it's being recorded, so you can watch it back later. So as always, do make notes. It's always handy to write things down. It helps you to take in the information. Those of you watching live, don't worry about this step. It might be easier just to listen and then make notes later on. I'll send you a link to the recording. So today we'll cover the basics of the kind of language of probability, how we describe probabilities in words. Then we'll look at how to describe probabilities as numbers on a scale from 0 to 1. How to calculate probabilities where you've got equally likely outcomes, so things like throwing a fair dice. We'll look at the probability of an event not happening. So if we know the probability of something happening, how do we work out the probability of it not happening? And then we'll look at a few past exam paper questions. So first of all, the basics of probability. So what is probability? What do we mean when we talk about probability? So the probability is how likely an event is likely to happen. So when we say an event, that's just the word for something happening. So an event might be throwing, getting a 2 when you throw a dice, or pulling a card out of a pack and getting a queen of spades. That's an event. And the probability of an event happening can be anything between impossible, so that means it definitely won't happen, or certain. Definitely will happen. It's harder than you think to think of definitely certain things. And you can put things on a scale like this. So we're trying to quantify it or make it numerical, mathematical. So at the very bottom of the scale here, just put my pointer tool on, we've got impossible. So what's an example of an impossible event? An impossible event might be throwing a 6-sided dice and getting a 7. That would be impossible. And then we've got words like unlikely. So it could happen, but it's not very likely. Even is the word we would use to say it's equally likely. So if you throw a coin, assuming it's not going to land on its side, throw a coin, the chances of it being heads or tails would be even chance. You're equally likely to get head or tails. Likely means it's probably going to happen, but it's not absolutely certain. And certain means it will definitely happen. So you roll a dice, the chances of getting a number from 1 to 6 is certain. That's just a few examples there. So here we've got an example for you to look at. We've got 4 cards, and one of them is just chosen at random. So imagine they're face down and they're all mixed up. So we've got 3 statements here, A, B, and C. And we're being asked to place them on the scale at the bottom of the screen. So we're not giving the probabilities numbers at the moment. We're just thinking about whether it's possible, unlikely, even chance, likely, or certain. So, event A. What is the probability that the card is a 1? What do you think it is roughly? Just type your suggestion in the chat box. Do you think it's impossible to be a 1, unlikely, even, or certain? Have a look at it. So the chance that the card is a 1. Just want to put the first letter, that would be fine, because there's I, U, L, C. So if you just want to type it quickly, then I will accept that. Give you a chance just to think about that. So the probability that the card is a 1. Christina, Emma, thinking unlikely. Yeah, it's unlikely. I mean, it's fairly likely, but it's not an even chance. It's not impossible because there is a 1. So out of those options there, the probability of getting a 1 would be unlikely. So it's less than 50-50, so I'll put it about there. And notice that this unlikely is about a quarter of the way along the line. And actually, if you've got 4 cards and they're each equally likely to come up, the probability of getting a 1 will be 1/4, 1 out of 4. And it's about a quarter of the way along this line. So that would be spot on there, unlikely. How about B? What's the probability that the card is 4 or less? So we've got 4, we've got 3, we've got 2, and we've got 1. Well, all of them are 4 or less. So whatever card you turn over is going to be 4 or less. The probability that one of those cards is going to be 4 or less. Brilliant. Everyone that says certain, good. Victoria, certain, good. Certain. So it's definitely going to be 4 or less. So the probability that it's 4 or less is certain. So we put that right at the far end of the scale there, 30. So you're giving these numbers, this would be 1 and this would be 0. We'll go on to that in a second. And then event C, what is the probability that the card is a 5? So we've got 4 cards, 1, 2, 3, 4, probability that it's a 5, brilliant. Good, Emma, Ramesh, Christina, Mia, impossible, good, impossible. Now when you do your actual GCSE exam, when we introduce probability, we give you an idea of the language that we're using. But please don't use these words in the exam, because usually, unless they actually say describe the probability or put it as a word, you will be asked to put your answer as a number. So please be careful of not putting these words in when you're asked to find a probability that you can calculate. You can calculate it, unless it's something, you know, like what's the probability that it will be sunny tomorrow or something like that. Probabilities should be given numbers. So there's C over there right at the end of the line. If you want some practice of this using the language of probability, there's a nice interactive worksheet here I'm going to give you a link to. So if you're watching live, you can click that now. It will open up in your browser and you can go back to it later on. If you're watching this as a recorded version, as WebEx, go to the top, click on view, open up the chat box, click on the link. It will open up in a new page. You can either pause the recording to work on that, or you can go back to it later on. Just a quick activity. That shouldn't take more than 5 or 10 minutes. So now let's have a closer look at probabilities as numbers. So all probabilities are on a number scale between 0 and 1. Now you might have things like gambling odds that you might have heard of, but in GCSE maths, probabilities are always given as fractions, and those can also be decimal fractions or percentage fractions. All equivalents will be accepted, but usually it's fractions or decimals. Now the probability that something is impossible is 0. So if something is impossible, we give that probability of 0. And the probability of an event that's certain is 1. So that means that all probabilities will be between 0 and 1, including 0 and 1. It can't be bigger, so you can't have a number bigger than 1. So if we're using fractions, the probability scale will look something like this. So we've got 0 at the bottom here, quarter, half, 3/4, and 1. If you were given a probability scale and you wanted to be accurate, you could put a ruler up against it, you could measure it, and then a quarter of the way along the line would represent a probability of a quarter or 1. Or 6, or any other fraction that you wanted. 6 would be a sixth of the way along, and so on. And we can also write probabilities as decimals or percentages. That would work as well. So let me just go back to this. So this would be 0.25 or 25%. Half as a probability could also be 0.5 or 50%. 3/4, that could be written as 0.75 or 75%. And 1 could be written as 100% as well. So here's another very similar example, but this time we've got some numbers written on the line. So we're told here that a fair 6-sided dice is rolled, and the scale below shows the probabilities as A, B, and C. So we need to match each one. So part A, what is the probability when we're throwing a fair? Now fair is quite an important word, and I'll explain that why that is. If we're rolling a fair a fair 6-sided dice, what's the probability that 6 or less is rolled? Is it A, B, or C? Type it in. Christina's put an answer already. You can put it as a number as well if you prefer. So there's 6 numbers on the dice. 1, 2, 3, 4, 5, and 6. So all of those, brilliant everyone that put C, it's going to be this one here. So this is the probability of getting a 6 or less. It's 1. So we put it at this end of the line. Now how about part B? What's the probability that you will get a 1? So with a dice that's fair, you've got an equally likely chance of each one happening. So if there's 6 possible outcomes, probability of all of them happening is 1, and 1 divided by 6 is 1/6. So the probability of each number is 1/6. They're all equally likely to happen. So it works a lot like fractions. So the probability of getting a 1 is 1/6. So we want the letter that's a 1/6 of the way along the line. So we've got halfway here. So this is the point here. This will be 1/6. Let me just write it on here. So this is 1/6 about here. If you were in the exam and you had a ruler, then I guess you could measure the line 6 centimetres. 6 away along the line would be 1 centimetre. You could do it like that. So that's 1/6. So the answer to part B is 6 there. Let me just reveal the answer there. 1/6. And then the last one, what's the probability of getting a 1 or a 2? So we can either get a 1 or we can get a 2 or a 3, 4, 5 or 6. So there are 2 numbers out of the 6 that are a 1 or a 2. 2 out of 6, you could write it as 2 over 6, that would be fine. But usually you cancel it down. So 2 out of 6, so 2 numbers out of 6 numbers possible altogether. Told you it worked a lot like fractions. That would be about a third of the way along the line. So that's 2/6, which is the same as 1/3. This is about double the distance. We've got this distance here, that's 1/6, and then this would be 2/6 here. So 2/6 along the line. And there's only one that's left as well, so part C, there's probability here. Now, it's quite a common question to get on exam papers if you're doing foundations here. On the first few questions, it would be a nice warm-up question. It will give you a probability line. It will give you an event, and you have to mark on the scale where you think that probability should be. Let's have a look in more detail at how we calculate probabilities. So there's kind of a formula that you need to learn. It's not too difficult though, it's just like a fraction really. So the probability of something happening depends on the total number of possible outcomes. So if it was something like rolling a dice, the number of possible outcomes would be 1, 2, 3, 4, 5 or 6. If it was picking a card out of a pack of cards, the total number of possible outcomes, not including jokers, would be 52 because there are 13 cards in each suit. I doubt that ones with cards would come up though. Some people don't use cards, so don't know. So that's just an example. So it's the total number of different things that could possibly happen. So this is the formula that we use for the probability of an event, is the number of ways it can happen out of the total number of possible outcomes. And really that should be equally likely outcomes. This formula doesn't work if the different outcomes have a different chance of happening. So this only really applies for equally likely outcomes. So that's quite important. So be very careful if you see the word biased in a question. If it's a biased dice, it means it might be weighted towards one particular number, so it wouldn't be equally likely. So it has to be equally likely for this to work. So let's have a look at some examples. We love ones with counters and balls that you pull out of bags. We've got a box with 20 coloured counters, and the counters are numbered 1 to 20. 11 of the counters are blue, 7 of the counters are purple, and 2 of the counters are yellow. If one counter is selected at random, work out the following probabilities. Now actually, the fact that they've told you that the counters are numbered between 1 and 20 is a bit of a distraction because the numbers don't actually count. So we're just interested in the colours. Oh no, we are interested in the numbers as well because we've got part A says the counter is a number 12. So there are 20 counters. One of them has a number 12 on it. What is the probability that the counter is the number 12? Be very careful, Christine, and I think that's why they've put numbers in, because so we've got 20 counters. What is the probability? So I could pull out a 7, I could pull out 10, I could pull out a 19. How many counters have the number 12 on it? Only one counter has the number 12 on it. So if I've got 20 counters and one counter has the number 12 on it, then the probability of getting a number 12 is 1 out of 20 altogether. Does that make sense, Christine? I know you're probably just typing it quickly. I know you get it, but it's useful when people get things wrong because then we can avoid common errors. So don't be misled by the fact that it's a number 12. Any of the numbers, if you're just picking one of them, will be 1 out of 20. Good. So we've got one number 12 out of 20 outcomes altogether. Don't overthink it. Just think, well, 1/20th of all the counters has a number 12 on it. So it's a lot like fractions, so the probability is 1/20th. How about the next one? What's the probability that the counter is yellow? So we need to read through the information again. This time we need to say, well, how many are yellow? So let's have a look. 11 are blue, 7 are purple, and 2 are yellow. So we've got 2 yellow counters out of 20 counters altogether. So that's 2 over 20. A probability, you don't always need to cancel things down, but if you want to cancel it down, you can do that as well. So 2 out of 20 is correct, and 1 out of 10 is also correct. They're equivalent fractions, so 2 out of 20 or equivalent. That would be fine. If you're in an exam and you were asked that question, you would probably get full marks for 2 out of 20 unless it told you to simplify the fraction. 1/10 would be fine, or 0.1 or even 10% would all be accepted as equivalent. So 2 ways of getting yellow, put the numbers in the formula, 2/20 or 1/10. Good. Now about the last one. What's the probability that the counter is either blue or yellow? Now, it can't be both blue and yellow. We'll be learning about and or rules and probability much later on towards the end of Unit 3. So what we do is we look at how many blue and yellow counters there are. So there are 11 blues and there are 2 yellows. So altogether, there are 13 counters that are either blue or yellow. So in other words, how many counters are either blue or yellow out of how many counters altogether? So Christina, Emma, 9. Have you subtracted? So think about how many blue and yellow counters have we got? We've got 11 blue, 2 yellow. So altogether we've got 13 chances of getting either blue or yellow out of 20 altogether. So if you put 13 out of 20, good Molly and Christina, good. Whoops, I've gone too quickly. So count how many we've got and divide by 20. No, we lost the slide there with the answer on. So the slide that's missing, I'll just write the answer on. So the answer for this one is we've got 13. Just change the colour. I accidentally deleted the slide. 13 over 20, and that doesn't cancel. So that's the answer for that one. Okay, so that's how it works, just like fractions. So here's an interactive worksheet for you to work on. Again, this won't take very long to work through. Just click on there. Type your answers in the boxes. The top number is the top of the fraction and the bottom number is the bottom of the fraction. So for example, for this question 1, it says, when you roll a fair dice, what is the probability that you obtain an odd number? I think you have to cancel them down as well. So an odd number, half of the numbers will be odd because you'll have either a 1, a 3 or a 5 that are odd. So you put 1 in the top and 2 in the bottom. So on. Just fill them in like that and then press check to check the answer. Perfect. Third, multiple of 3. Yeah, multiple of 3 would be a third, that's right. Just click on that link and have a go at them. It won't take very long. So multiple of 3, you could have 3 or 6. So that would be a third of the numbers that are multiple. Okay, so have a go at that. And there are some more practice questions in your course notes there. So how do we work out the probability of something not happening? This is sometimes called complementary events. So something is either going to happen or it isn't. So this kind of comes round to the fact that either something's going to happen or it isn't. So in other words, both those things together have to add up to 1. So if we know the probability of something happening, then the probability of it not happening must be 1 subtract the probability of it happening, vice versa. Oh, there's that missing slide. I must have just got them out of order there. Okay, so events that can't happen at the same time are called mutually exclusive. You don't need to learn that word, but it will come up from time to time when you're talking about probabilities. So a little bit like when we had the counters and we had either a blue counter or a yellow counter, but they can't be blue and yellow. Those are mutually exclusive. We can add them together if they're mutually exclusive. So if they can't happen at the same time, they're called mutually exclusive. So for example, rolling a 1 and rolling a 3 on the same dice are mutually exclusive events. They can't happen at the same time, either one or the other. Now the probability of all mutually exclusive events covering all possible outcomes always add up to 1. So if we take the example again of rolling a dice, we've got 6 numbers. Probability of getting a 1 is a 6, probability of getting a 2 is a 6, probability of getting a 3 is a 6, 4, 5, all of them is probability of a 6, and when we add them all together we get 1, because it's going to be one of the numbers. Now, the probability of something happening And the probability of it not happening always has to add up to 1 because it's certain it's either going to happen. So the probability that something doesn't happen is always going to be 1 minus the probability that it does happen. And this fact can be quite useful in solving more complicated probability problems later on. So if you're doing probability tree diagrams and things like that, this can come up. So left the formula there at the top for you to look at. We've got an example here. So Jim gets the train to work every day. The probability that his train is late on any day is 0.05. What is the probability that it's not late? So it's either late or it isn't late. Now this time we've been given the probability as a decimal. That often happens because it depends how the probability has been presented. So if you're given the question as a decimal probability, you usually put the answer as a decimal probability. Any ideas? What we want to do, if the chance of it being late is 0.05, and the probability of it not being late is 1 minus 0.05. Do it in your head. Christina, you've got an answer, and Emma, anyone want to something else? So we want to subtract 0.05 from 1. That would give you 0.95. Right, we're subtracting those. If you want to, think of it as 1.00. It's a little bit like 100. And if you were to subtract 5 from 100, that would give you 95. So that's where the place value decimals come in. Hopefully you can do that step in your head. So if we subtract those two numbers, we get 0.95. You okay with doing that mentally? So the way I would think of it is 100 minus 5. Just move the decimal point 2 spaces. But just don't forget to put the decimal point back in. That's probability of it being on time. Okay, now these kind of tables come up a lot in the exam where you've got 4 different things in the probability of it happening and you have to work out the missing one. Almost always comes up in the exams. So here we've got a bag that contains red, green, blue and white counters. We don't know how many there are of each one, but the table shows us the probabilities of randomly selecting each colour. We could guess how many there might be in the bag, but we couldn't work it out exactly roughly. And it says work out the probability of selecting a blue counter. So bearing in mind that these 4 numbers have to add up to 1, so the 4 probabilities added together because we've only got red, green, blue, white. How do we work out the missing one here? So the way I would probably do it is I would probably add together these 3 numbers. Let me just put my pointer back on. 0.2, 0.1 is 0.3, and then add on 0.5. That gives us 0.8, and then subtract that from 1, and that will give us the missing number. So they're mutually exclusive. You can't get red and green. It's got to be one or the other. So we add them together like this. So 1 minus 0.8. Good. And Emma as well. Brilliant. You've actually typed in a whole sentence. Well done. The probability of blue is 0.2. Right. Perfect. 0.2. So we just need to make sure that these numbers all add up to 1. Here is a worksheet that you can have a go. Complementary events. So, for example, let's just have a look at question 1 here. The probability that Scott will win his next darts match is 3/5, 3/5. What is the probability that he will not win? So remember that 1, if we're talking about fifths, is going to be 5/5 or 5/5. So if the probability that he wins is 3/5, the probability that he won't win will be 2/5. Does that make sense, Christina? Good, yes, 2/5. So what we're doing is we're subtracting these from 1. If we work out 1 minus 1/8, that's going to be 8/8 minus 1 or 7/8. This one will be 13/20 and so on. Useful to be able to subtract any fraction from 1. And there are some practice questions here. Really whizzing through this session. It's just really the very basics of probability. So we'll look at some exam questions as well. So here's some examples of the kinds of easier probability exam questions that you might get. So let's have a look at the first one. So we're told that there are 100 beads in a bag. 50 of the beads are red, 25 are blue, 15 are green, and the rest of the beads are yellow. We don't know how many are yellow, but we can work it out since we know the total is 100. So Sally takes at random a bead from the bag. What is the probability, this is part A, what is the probability that the bead is green? Type it into the chat box and then we'll see if you're right. Emma, you're putting it as a decimal, that's fine. Christina, you're doing it as a fraction, that's good. Either will be accepted, so that's fine. Anyone want to put anything different? There's one more way that you could perhaps write this down. Do it as a percentage, or you could cancel down the 15 over 100. That'd be fine. Brilliant, Victoria. Well done. That's what the other possibility that I was looking for. So yeah, so you don't need to write down the formula, by the way, for this. I'm just writing it down to show you where it comes from. So the number of green beads is 15. Out of the total number of beads, it's 100. So 15 over 100. You can also write it as 3/20, 0.15, or 15%. Those would all be accepted in the exam. Brilliant. And we've got, thank you, Christina, 15%. So every possibility. So all of these are equivalent. They're all different ways of writing the same thing. And so unless it tells you in the question to write it in a particular way, you can write any of those. Part B, what is the probability of black? Written in any form that you want, because the question doesn't tell us what form to write it in. So the probability of black, brilliant, well done, good. Don't write impossible, give it as a 0, so it should really be as a number. And so put 0, so no blacks for the probability of 0. I'm not sure if they would accept impossible, but really unless it says otherwise, write it down as a number. So if you put 0, that is perfect, well done, because there are no blacks. We've only got red, blue, green, and yellow. How about part C, which is yellow? So we have to do a little bit of a sum here because we are not told the number of yellows. We need to add these numbers together. So 25 and 15 is 40, plus 50 is 90. 90. From 100, 100 subtract 90 is 10. 10 out of 100. So lots of different ways that we could write this. 10 over 100, 110, 0.1, 10%. Christina and Emma, good. 10%, Christina, good. And as a decimal, what would it be as a decimal? Anyone? Okay, that's what I'll show you. Careful, Christina, that's 100. So it's 0.1. Good, Victoria, perfect. So 10 out of 100 would be 10 over 100 like this, or you could write it as 1/10, or 0.1, or 10%. Perfect, good. Now, as I said, they like having these probability scales as well in the exams. Here's another typical Excel question. So on the probability scale below, you can't do this if you're watching live, you can maybe describe to me where the cross would be. Work out, mark on there the probability that a woman has 20 sisters. Now, it's not an exact number, you're just really showing that you have a feel for whether this is very unlikely or very likely. So what's the probability of a woman having 20 sisters? It's not impossible. It's definitely not 1 in 4. That's actually quite likely. It would be very unusual. If you met someone and they said, I've got 20 sisters, that would be very unusual. So it's very unlikely. So I would put the cross close to the 0. Not on the 0 because it's not impossible, but close to 0. It's not a very likely thing. So it's this test, this is really just to test your feel for how probable things are. So it's very unlikely, but not impossible to put it as close to the 0 as possible. That seem reasonable? Now for the second bit, this one's much easier because it's something we can actually work out. So there are 6 red beads and 3 green beads in a tin. Adam takes at random 1 bead from the tin. On the probability scale below, mark with the cross probability that Adam takes a red bead So there are 6 red beads out of 9 beads altogether. So it's 6 out of 9. You can write 6 out of 9, and you can maybe cancel it down, and that'll give you a better idea for where it is in the line. So 6 over 9. Just write that down. So 6 out of 9 altogether is the same as 2/3. So you can kind of say, well, 1/3 is about here, 2/3 is about here. So that's where you want to put your mark. It will give you an error margin, and if you've got a ruler with you in the exam, and you should have, it might be an idea to measure the line, find 2/3 along a bit more accurately, and draw the x. But the x will be about there, about 2/3 of the way along. That makes sense? Perfect. Let's see, let's do it 2/3. Let's have a look at another one. So here we've got a 4-sided spinner, and the sides of the spinner are labelled A, B, C, and D. Now we're told the spinner is biased. Now what we mean by biased when we're talking about probabilities is that they're not equally likely to happen. So you're more likely to get a B than you are to get a C, and so on. So maybe the lengths are slightly different lengths, so it's more likely to land on one side than one of the others. Now we're given the probability of getting A, B, and C. We're told that A is 0.5, B is 0.32, and C is 0.27. And part A says, work out the probability that the spinner will land on D. So what we need to do then, you can use a calculator if you want, if you're watching live, add these 3 numbers together, and then you need to subtract those from 1. So let's add these numbers together. You could line them up in columns and work them out as well. We know that they have to add up to 1. So if we add these 3 numbers together, you could add up the units and the 10 separately or use a calculator. You would get 0.74. So the probability of it landing on D is going to be 1 minus 0.74. So that will give us, yep, I'm just looking in the chat box there to see who's got the right answer. Good. 0.26. 0.26. Perfect. Right. We've got some time. So who would like to do some more practice questions? I can bring some up on another screen since I've finished very early. Covered really most of the basics of that. Who would like to do some more practice questions, or I could just finish the session early. Let you try some questions yourself. Yeah, okay. Let's just spend a few minutes looking at some practice questions. So what I'm going to do is I'm just going to I'll just use some questions from MathBuster. CGP MathBuster. I've got a copy of that on my computer. A second. I will share my desktop. Should definitely. They've said that. No. Okay. Those of you that are watching live, you probably have noticed that the chat box has disappeared. I'm just going to move this over. Go to the top of the screen with your mouse, move all the way up to the top, and then click on chat. And then once you've got the chat box open, just say OK or something, just to let me know that you've got the chat box open. Brilliant, Victoria. And then you can still help me answer the questions. So good. Okay, so what you're seeing here is I've just got a copy of this MathBuster from CGP. Don't have to buy this, but it's quite good for generating random questions. So I will share it with you today. So I've just clicked on Browse Revision Topics, and then I'm going to Statistics and Probability. And then these are the probability topics. Now, we're just at this end here for the grade 1 to 3 topics. So we've looked at the probability scale. Okay, sorry the sound cut out there. I think I pressed on the mute button. All right, so we're just looking at these revision slides. So we've got the formula here for working out the probability of something happening, and we've got the probabilities adding up to 1. So let's have a look at some of the practice questions then. So let's start with question 2. I think question 1 is too easy. So those of you watching live, just type your answers in the chat box and then we can correct or not. So we've got a picture here of a fair six-sided spinner. And we're told that the spinner is spun once. What is the probability of it landing on a 4? Give your answer as a fraction in its simplest form. So when it says that, you have to write it in the way you're told to in the question. You can't write it as a percentage, you can't write it as a fraction that hasn't been cancelled. You have to write it as a fraction in its simplest form. So, answers in the chat box, please. What is the probability of it landing on a 4? What do you think? So the first thing to do is to say, well, how many 4s are there on the spinner? So there's 1, 2, 3 4s altogether. And how many possible outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, six-sided. So the probability of it landing on a 4 will be 3 out of 6, or 1/2, because there's 3 of them. Does that make sense? Let me just show you. So, tool on. So there are 3 4s out of 6 numbers altogether. So if I simplify that, it will come to 1/2. Divide top and bottom by 3. Okay, does that make sense? So in here, type in 1 over 2. Let's check if we're right. Correct. Hey, we did it. Let's have a look at another one. I think these get progressively more difficult. So Aisling picks one of the random shapes below. Find the probability that her shape is a black circle. So how many black circles are there altogether? And how many shapes are there altogether? It's a little bit like asking what fraction of these shapes are black circles. So have a think about it. We've got a couple of different suggestions. There are many in here. So I'm going to start typing in here. Victoria, you think 2 9? Christina, you agree? So yeah, two are circles. So 2 goes on the top. And then underneath, total number of shapes is 1, 2, 3, 4, 5, 6, 7, 8, 9. Easy. Good. Mark. That's right. Correct. Much easier than algebra, isn't it? All right. Here we've got a box contains 4 blue and 5 green counters. One counter is selected at random from the box. Find out the probability that the selected counter is blue as a fraction in simplest form. Well, we've got 4 blue counters and 5 plus 4 is 9. So 9 counters altogether. So what do we think? Victoria and Christina, anyone else still watching? Remember, if you can't see the chat box anymore, you need to take your mouse, drag it to the top of the screen, and on the drop down, click on the speech bubble there. So you can have a go at it. So 4 over. Quite easy so far. Hopefully we've got some more challenging ones in a second. Let's have a look. Good. Next. Cake tin. 4 cherry, 3 cheese, and 4 plain. One's gone taken out at random. Find the probability that it's cherry. Still very easy. So cherry. We've got 4 cherry. And altogether, 4 plus 3 is 4, 11, Christina, 4, 11, 4 over 11, let's have a look, 4 over 11. Let's see if we're right. Good. All right, next one. So, we've got a fair 6-sided dice. Find the probability that you get a 5. Quite easy. So 6 numbers on a dice, only one of them is a 5. So that's going to be 1 out of 6. So 1 over 6. So 1 5 out of 6 numbers altogether. Let's get all of these right, I think. How about part B? one card is selected randomly from 7 cards numbered 1 to 7. Find the probability that the number on the card is more than 2. So let's be a bit careful here. More than 2 doesn't include 2. So we've got 3, 4, 5, 6, 7. Don't worry about using your fingers. I use my fingers all the time. So there are 5 cards that are more than 2 out of 7 cards altogether. So it's going to be 5 over 7. 5 out of 7 together. And the last one here, we've got a fair spinner, 10 equal sections. 1 section is red, 2 sections are blue, and 3 sections are green, and 4 sections are yellow. Find the probability that the spinner lands on blue or green when it's spun once. So blue or green, 2 are blue, and 3 are green. So that means 5 are green altogether. 10 sections, 5 out of 10 gives me half of them will be blue or green. That makes sense. So 5 over 10, I think it's 1/2. Does it say to cancel them down? Yes, fraction in its simplest form. Let's check that. So that will be 1 over 2. All right, good. Right, they're getting progressively more difficult. Let's see what the next one is. So we've got a large box. It's got 100 tickets in it, all mixed together. 9 are for holiday to Nepalia, 38 are for a leak, and the rest are for nothing. Oscar picks a ticket at random. Find the probability that he wins nothing and give your answer as a fraction in its simplest form. So what we need to do here, because we're not told how many or nothing, is we need to work out the total offer that offer something. So 38 plus 9. As we can use a calculator. I don't have my calculator on my desktop here today, but you guys can maybe use that. I could probably do it in my head. 38 plus 9 is 47. Subtract that from 100. That gives us 53. Thank you, Victoria. Let's see, 53. Oops. So 53 over 100, and it can't be cancelled down. So I think that's right. Let's have a look. Perfect. We'll do a couple more. So for part A, we're told that the probability that it's going to rain in Clovelly is 0.01. What's the probability that it won't rain? We're supposed to give our answer as a decimal. So what we need to do here is work out 1, subtract 0.01. Now, it says you can use a calculator, but you can probably do this in your head. It's a little bit like 100 minus 1. So we should be left with, just maybe someone in the chat box tell me what they think. 0.99. Yep, so Victoria, 0.01 is 1 over 100, good. So the probability that it won't rain will be 99 out of 100. And if you turn that into a decimal, you'll get 0.9. Okay, good. For part B, it says a packet of jelly sweets has got yellow and purple sweets only. The probability of selecting yellow is 1/19. So what's the probability of selecting purple? So you're definitely going to get one or the other. So it's certain that you're going to get a purple or a yellow. That's 1. So if 1 out of 19 are yellow, it means that how many out of 18 are perfect? Good, 18 out of 19. So let's put 18. That makes sense? Out of 19. Good. And then the last one, it says the probability of a rugby team winning their next match is 91%. So you've got percentage probability as a percentage sign. Find the probability that they either lose or draw their next match. So the probability of winning is 91%. 1 in percentages is 100%, all of it. So we need to subtract 91 from 100, and we get 91 minus 100 is 9. So they're either going to win, lose, or draw. So 9% chance of getting a lose or a draw in this match, I think. Do you agree? Okay, let's see if we've got all of those right. Right, yes, we've got them. We'll do one more, and then I'll bring the session to a close. So we've got up to 10, just make it a nice round number. So this tells us that a van is transporting a large number of carrots, potatoes, penguin mugs, and fluffy dinosaurs. The table below gives us the probabilities of randomly selecting each type of object from the map. So what we need to do for this one is we need to add together 0.16, 0.11, and 0.46 and subtract that from 1. What are we left with? And you can use a calculator if you want to. I don't have my calculator with me now. So someone would like to work that out for me, and we'll see if you're right. Do we think 0.27, 7? Yeah, something like that. That's right. 0.27. Good. Well done. One more. By the way, if you do have this Maths Buster DVD from CGP and you are stuck on one of the questions, you can just click on the show a work example and it will show you an example of the question worked out so you know what to do to add the numbers together and take away from one. So let's do this last one. So a spinner has sections coloured scarlet, mint and black. When a spinner is spun once, the probability of it landing on the scarlet section is 0.3. and the probability of landing on the mint section is also 0.3. What is the probability of landing on the black section? I'll give your answer as a decimal. So this is just the same as the last one, but with a lot more words in it. So what we need to do is we need to add these two together. That gives us 0.6. Subtract that from 1. That will give us 0. Okay. Mark that. Correct. Okay, brilliant. Easy lesson today. Let's stop sharing this now. I'm going to just give you some more practice. Hegarty Maths has got some exam-style questions if you want to try these on his video. Now, some of these go into what we'll be covering at the end of Unit 2, which is the experimental probability. So if you know the probability of something happening and how many times, for example, you roll a dice, then you can work it out, the theoretical probability. So most of those problems are theoretical probabilities. You can have a look at them if you want to, especially if you found today's session quite straightforward. Now, on the Maths Genie page, if you want to watch the video, you just click on probability. This is in the grade 3 section. So scroll down the page until you get to the grade 3 section. I'm just putting the link into the chat box now. So it's right at the bottom, just before two-way tables. Click on probability to watch the video. Then have a look at the questions. This one will download a worksheet where you can actually write your answers in the spaces and then solution steps. So that's just basic probability in there. And in your textbook, the first two sections, if you're doing higher tier, still advise that you start with the foundation to textbook. So I'm just giving you the link here to probability basic section 1. Have a go at those for some more practice questions. And if you're using this workbook, it's page 100 for some practice. Okay, pretty easy. Now we'll be revisiting probability at the end of each of units 1, 2, 3, and 4. So we'll go back to some more difficult probability, including experimental probability in section 33. So if you found that today's session was a little bit easy and you want to try some harder questions, you can skip ahead to the end of unit 2 if you wish. If you've watched all 15 of the first session, 16, then that means you've finished all of unit 1. If you've finished unit 1, then please do the test paper. Next session, Kirsten will be covering factors, multiples and primes. So we did that in session 3, but this will really go through some more difficult examples once you've finished unit 1. If you finished all of Unit 1, got to the end of session 16, please do take some time to work through the Unit 1 test paper. That will give you the chance to get some feedback from your tutor and see how you're getting on with the course. You don't have to do it, but it's a good idea if you do. What you do is you print it out, fill it in pen, and then I would download a scan app. Scanning out something like Adobe Scan is very good. Scan each of your pages, it will combine it into one document, and then you can upload it to your tutor to mark. Or you can just take a photo of each page. If you don't have a printer, you can write your answers on paper and then take a photo of your answers that way and paste them into a Word document or use a scanning app, as I said. So have a go at that test paper once you finish Unit 1. Victoria, if you want just exam-style questions covering algebra, then let me know and I can find some of those for you. There's a website called Just Math. Let me just find the link for you. Give me a second. I'm just going to pause the recording. Sorry. So here is a link to the Unit 1 test paper. So as soon as you finish Unit 1, do the Unit test paper. Okay, that's just about it for me for today. Any more questions? Anything you'd like to ask me? Feel free to type it in the chat box. If you enjoyed the session, found it helpful, it's always nice to get a bit of feedback on Trustpilot. So if you want to let me know your thoughts if you found the session helpful. Sorry about the sound cutting out halfway there. Of course, all of these sessions are recorded live, so sometimes there's a few technical errors. Please just click on that link and do mention my name if you enjoyed the session. I will see you next time. Kirsten will be running the Tuesday evening session, and I'll be back next time too. Any feedback, please do just send me an email. You can contact your tutor if you've got any questions, or student services if it's not maths related. Okay, glad to hear that, Christina, and hope to see you next time then. Bye.